Hello, hello everyone. Today I'm going to discuss about the Euler's theorem for homogeneous function. And in the last lecture, we have studied about the partial differentiation of the function, which is having independent variable x and y. So here we will study the Euler's theorem for homogeneous function. And now we consider that z is a homogeneous function of xy of order n, then x del z o by del x plus y del z by del y is equals to nz. This is the statement of the Euler's theorem for the homogeneous function. Now we can prove this. How? See, first we will consider that z is a homogeneous function of xy of order n, and we can write that homogeneous function in this form. That is, z is equals to x to the power n dot f y by x. So in order to prove this Euler's theorem, we can write z is equals to x to the power n f y by x. Some pronounce it as Euler's theorem also. In Euler's theorem, I pronounce it that way. So now we have taken that z homogeneous function in this form, and to prove this Euler's theorem we have to calculate its left hand side using this function, and that must be equal to the right hand side. So in the next we will take the partial derivative of z with respect to x and multiply with x plus y, and partial into partial derivative of z with respect to y. So we have to first find out the partial derivative. So in this we will write x. Okay, z we have taken, z is equals to x to the power n f y by x. Okay. So we will do its partial differentiation with respect to x. That will be, first we will differentiate this first quantity nx n minus 1. Second quantity will remain the same. Then we will differentiate second quantity, that will be equals to f dash y by x nx n minus 1. That means minus y is with that, because here we take the y as constant. So this is del z by del x, and x del z by del x will be equals to, you multiply with x in this. Okay, so when we multiply x, then x to the power minus 1 plus 1 will be x to the power 0. So we are left with nx n for the first term, f by x plus x n minus 1 f y by x into minus y. Yes, we have multiplied with x, here only 1 by x remain, and that 1 by x we have written as x to the power n minus 1. So we can write it as nx n f y by x plus x. Okay. We will take minus sign here, minus y x n minus 1 f. Okay, this is f first derivative this function. Now we will take the partial derivative with respect to y. Delta z by delta y is equals to, first quantity will be treated as a constant and we will take the derivative only of the second quantity, that is f dash y by x into 1 by x. So we get x n minus 1 f dash y by x. Now we multiply with y delta z or delta y is equals to, multiply with y x n minus 1 f dash y by x. We have given the equation 1 to this and 2 to this and 3 to this equation. So we can add equation 2 and equation 3, and on adding equation 2 and 3, what we get on the LHS, we get x delta z by delta x plus y delta z by delta y is equals to nx n f y by x, and these two quantities are similar, so they are cancel out each other. So x to the power n f y by x is equals to z. So we can write here n z. This is equals to z. So we have written is equals to n z. So this proves the Lagrange, this proves the Euler theorem. So I want to clear that this is not similar to the Euler's Lagrange theorem. Euler's theorem is different from Euler's Lagrange theorem. So Euler's theorem is x delta z by delta x plus y delta z by delta y is equals to nz. So this theorem we get when we are having two variables x and y. But if we are having more than two variables, let's say we have three variables, or we say that if u is a homogeneous function of order n, function of three, let's say three variable x, y, z, and its degree is n of degree n. Then we can write x del u upon del x plus y del u by del y is equals to, so we are having only, or we are having one more variable, so we write z del u by del z is equals to n u. Then we can write Euler theorem in this form. So depending on the number of variables we have, this tells the degree, that is n is the degree, and these are the variables on which the function depends. These are the independent variable on which the function depends. Now we can have one more deduction from this Euler's theorem. That is, we can write that if this is the deduction okay. So deduction from the Euler's theorem, what we can write that if Z is a homogeneous function of x, y, of degree n, and Z is equals to f of u, then x delta u by delta x plus y delta u by delta y is equals to n f of u divided by f first derivative function of. So we can prove this theorem. We can prove this theorem considering that z is a homogeneous function of xy of degree n. Z is a homogeneous function of xy of degree n. We have Euler's theorem, so we can write that x delta z by delta x plus y delta z by delta y is equals to n z. And now z is equals to f of u. Okay, so z is equals to f of u है. So we can find out delta z by delta x, that will be equals to f dash u and delta u by delta x. This u is a function of x and y. So we have taken the partial derivative with respect to x. Now x delta z by delta x is equals to x f dash u delta u by delta x. Similarly, we find delta z by delta y is equals to f dash u delta u by delta y. And f, okay, here we have to multiply with y, delta z or delta y is equals to y f dash u delta u by delta y. Okay, so x delta z by delta x plus y delta z by delta y is equals to x f dash u delta u by delta x plus y f dash u delta u by delta y. So we take f dash u common from both the terms and we get f dash u x delta u by delta x plus y delta u by delta y. And here on the LHS we have x delta z plus y delta z by delta y, and that is equals to nz from the Euler's theorem, and this nz is equals to nf of u, right? Nf of u. This z is equals to f of u, so we have written here. So from here we can say that x delta u by delta x plus y delta u by delta y can be written as, the next we write x delta u by delta x plus y delta u by delta y is equals to n f of u divided by f dash u. So this is one of the deduction from the Euler's theorem. So we can use this Euler theorem to solve some questions, and in the next class we will, in the next lecture we will see this, we will see some of the example related to the Euler's theorem. So thank you for today. I hope you might getting something from this. So subscribe my channel for more videos. Take care.